Hey, it's Random Code here, and today we're going to continue with Advent of Code, and we're now at day 8. And day 8 is not the hardest, but takes to acquire you're kind of familiar with the mathematics. But the first part, we have some kind of input, where we have some kind of node, and from node AA, you can then either go left to node BBB, or go right to CCC. We then note our movement pattern is going to be right, left, and we are done when we hit dot triple set. So we will start at AA. The first time we're going to go right, so we're going to go to CCZ. Second time we're going to go left, so we're going to go to set. And in this case, it took 2 steps to hit the goal. So that is more or less the first problem. We then get this relatively large file with a bunch of nodes and a bit more complex movement pattern. My idea is then very simply that we input all of these nodes in a map, where we end up having a map of key being the name of the node, and the value being a list of the 2 options, where we're just simply going to map left to index 0 and right to index 1 in that. We then first need to kind of like build our nodes map and extract our directions. So I just read my input line by line, get my first line, which is my directions, just turn them into a list of characters, and I then just go through the next steps from line 2 and forward. And for each line, I just simply do a bunch of splitting, extracting, but the simple thing is that I simply extract the name of the node, input it as the key, and then insert the 2 paths we can take left and right as parts of a list. So here we get current node, gonna be values, which is the input from our line. We get the left side of the equal sign, trim empty spaces, that's our key, our current node. And we then just go through a bunch of splitting and removing the parentheses, and we end up having our 2 directions. We then need to do this once in part 1, so relatively simple. We have a starting node, AAA, and because it's put inside a hash map, our extraction is actually going to be quite fast. It's going to be constant time. And we then just very simply just loop through while our current node is not equal to set. If our path is empty, we just reinsert the path, because we just keep going the path. But at first we just have the path being, for example, left to right, as before. We then very simply just remove the next move from our path. So list of left and right moves. Move it, map to 1 or 0, based rather than it's right or left. We then get the current node, so simply from our map, node, get by key, and pick the specific path we're going left to right, index 0, 1. Increment our path counter by 1, and then we just keep going this while loop until our next node is going to be triple set. And this runs relatively fast. It takes a few milliseconds, like 0.04 seconds, and then get that we have visited 17,000 nodes. So not too complicated. Part 2 is then similar, but another layer of complexity is added as always, where we now have 6 inputs, and for each of these inputs, we need to find at which turn, if they just keep going, because also the set values kind of like goes in some kind of like ring, so they're gonna keep hitting the same pattern over and over and over again. But we then need to find at which point, at which path count, does all 3 of these 6 beginning positions end on a ending position. And how we get this beginning position is that we just take all inputs having an A as a last digit, and they're all in a finishing state when they have set in the last digit of their current. So at first I thought I could just brute force this, but it turns out I think it's like supposed to take like 60, 70 days if I brute force it, just doing quick calculations, so that's not possible. But then actually looking online and finding some inspiration, I have found that the trick is more or less to use this LCM algorithm, which is the lowest multiple shared, meaning we just find the number that both numbers actually can be multiplied to. So for example, if we had inputs of 6 and 4, we need to find a number where both of these numbers can be added or multiplied by an integer, and we would have no leftovers. So in this case, it's gonna be 24, because 6 times 4 is 24, and 4 times 6 is 24. But then what we need to do is that we simply find for these 6 inputs, we now end up having a list of path to first goal. So we just simply, for each input, just find the path to a first goal. And we then simply using the LCM algorithm finds first for like path 1 and path 2, at which path count does these two solutions intersect. And then the combined intersection is then found between the combined intersection of 1 and 2 to this result, to intersection of 3. Then just simply end up finding a number, which is then the lowest multiple shared by all of these 3 numbers, or 6 numbers in this case. And if we then run it, we end up getting that our result is very large numbers, which would take forever to brute force, because we would need to do this amount of iterations for each of the 6 paths. But using this LCM is kind of like a small nifty trick to find like the connecting numbers between these paths. So the trick, actually just doing the exact same thing we did in part 1, finding the first solution for each of these 6 inputs, and then using the LCM to find the least multiple for all these 6 numbers combined. And it ended up being a very, very large number. But it exists, and it's a way, way faster way of doing it than just brute force. So I hope you enjoyed this shorter showcase of day 8. If you did, please leave a like and subscribe, and I wish you all a wonderful